Welcome to the Water Resources Podcast. I'm your host, Bridget Scanlon, from the Bureau of Economic Geology at the University of Texas at Austin. This podcast is produced in partnership with the National Academy of Engineering. In this podcast, we discuss water challenges with leading experts. So today I would like to introduce Dr. Chris Funk, our guest on the podcast. And Chris is the director of the Climate Hazards Center at the University of California, Santa Barbara. And he's a lead scientist with the Famine Early Warning System Network, and also published a book this past year titled Drought, Flood, Fire, How Climate Change Contributes to Recent Catastrophes. So we're delighted to have Chris chatting with us today. And Chris, I think it would be great to start off with your recent blog posts and everything on the Eastern Horn of Africa, and maybe a little bit of background on the Famine Early Warning System Network, FuseNet, and what you think is happening in East Africa these days and what the outlook looks like.
Okay. Thanks, Bridget. Yeah, so maybe I'll start with back in 1984, which was the year of a terrible famine in Ethiopia and Sudan, where more than a million people died. And, this was a really huge travesty. And in response to that, the U.S. government and the U.S. Agency for International Development set up the Famine Early Warning Systems Network, which has been a really important part of preventing a catastrophe of that magnitude from reoccurring. And a lot of that monitoring efforts that they focused on have been in East Africa, because that's a very food insecure and poor area that is really exposed to both extreme droughts, and extreme flooding events. And in the last, say, 6 or 7 years, it's been really hammered by a series of intense shocks. And that began in 2015-16, when a really strong El Nino event, which is when the Eastern Pacific is exceptionally warm, produced severe drought in northern Ethiopia, helping to push some 15 million people into extreme food insecurity. And then we transitioned to La Nina climate, which is associated with really cold ocean temperatures in the Eastern Pacific and warm temperatures in the Western Pacific. And there was a sequence of repetitive droughts in East Africa that pushed another 13 million people into extreme food insecurity. And then in the spring of 2019, there was another drought for reasons that we don't really understand. And then there was a well-known climate phenomenon called a positive Indian Ocean Dipole, which is, this one was really exceptional. It was, had the warmest ever ocean waters off the coast of Kenya and Somalia. And those brought in really intense moisture transports, and we had extreme flooding, both in the fall and then into the next March, April, May season. And that helped kick off this big locust infestation, the worst locust infestation in 70 years. And that was really a big problem for a lot of farmers. And then we transitioned in the summer of 2020 into a La Nina-like climate, which has persisted now, since the fall of 2020. And that's created repetitive droughts in Eastern East Africa that, as far as we can tell, are unprecedented as far back as the record goes to about 1950. And it's had just incredible impacts in terms of food insecurity. In Ethiopia, Kenya, and Somalia, more than 9.3 million livestock have died, and something like between 19 to 23 million people are expected to face really extreme food insecurity, kind of on the edge of famine. And frankly, it's, we're very concerned about actual famine breaking out. And so go ahead.
No, no, no,
Yeah.
no. I mean, so it's a sequence of wet and dry cycles, but I mean, long-term droughts and then flooding periods, and both are catastrophes for the food security because, I mean, there's very little irrigated agriculture in those regions, and so they're really vulnerable to the climate. And I think that's what's emphasized there. And you're discussing the connections then with the climate teleconnections or El Nino, La Nina, and things like that. So that's really cool. So what does it look like now and coming up in the near future? What do you think the forecasts are telling you, or what do the data
It,
suggest?
the forecast looks really tragically like a perfect ocean for drought. And, we've been discussing, the kind of two most important climate drivers for East Africa are El Ninos and La Ninas, which have to do with the Pacific Ocean, and then the Indian Ocean Dipole, which has to do with the Indian Ocean and whether it's warm in the west or the east. And the perfect ocean for drought for East Africa is when you have a La Nina associated with cool East Pacific temperatures and negative Indian Ocean dipole associated with cold waters to the east of Kenya and Somalia. And then in the Indo-Pacific warm pool, which is kind of that area where the Indian Ocean and the Pacific Ocean meet, the forecast models are predicting really, really exceptionally warm ocean conditions. And what that does is amplify the water circulation, which basically is drawing in moisture and heat into the area around Indonesia. That gets rainier than normal. The air ascends and then goes to the west and descends over Ethiopia, Kenya, and Somalia. And so, we're just about to post a blog in partnership with our colleagues at NASA, saying that we think it's very likely that this region is going to experience a fifth drought, and not just a fifth drought, but probably a very dry fifth drought. And something that you can appreciate, Bridget, there's kind of two pieces of this. One thing is that the water in the soil has really been depleted. And so the hydrologic simulations from our friends at NASA are showing that even if the rains are normal, the soil moisture conditions are still going to be below normal. And then our group here at Santa Barbara is contributing, a kind of analog analysis that's showing that because the models are predicting, a strong gradient La Nina and a really negative Indian Ocean dipole, that we think the likely outcome is going to be a very, very poor rainy season. So you have kind of both of those things convolving.
And so that's for October, November. There are two rainy seasons in the Eastern Horn of Africa, right? So October, November,
Yeah,
December, and March, April, May. So this October, November, December will be very dry. What about March, April, May next year? Do you have forecasts for
yeah,
that also?
yeah. So the paper that I'm working on right now, well, so let's begin with the statistics. So the statistics say that since the Western Pacific warmed up following the 1997-98 El Nino, there have been 12 La Nina events, which is a lot, right? Almost every other year. And whenever there's been a La Nina condition in October, November, December, um, 75% of the time there's been below normal March, April, May rains the following season. And this is the piece of the puzzle that we think is really tied to climate change. And so I've been just working feverishly on this because it's so, potentially important. And what that research is really showing I think in a very convincing way, is that, when there's a La Nina, let's say that it's October and there's a La Nina condition, we know that that amplifies the trade winds over the Pacific, which is, the most steady, energetic, persistent, set of winds in the tropics, right? And those blow more strongly to the west. That transports more heat out of the eastern Pacific, and then it turns in the subtropical gyre, right, and moves up into the North Pacific and the Southern Pacific, and creates warming in this area that I call the Western V, which kind of starts in Indonesia and radiates to the northeast and the southeast, and produces La Nina-like climate, even if there's no longer a La Nina. And so that that pattern continues to amplify the trade winds, even if La Nina fades, and brings in heat and moisture into the area around Indonesia, amplifying the water circulation in a very predictable way. And this can explain why then there's subsidence and reductions in moisture in East Africa very often following OND La Nina, October, November, December La Nina.
Right. And so when we have drought in East Africa, then, we often...
6 times.
6 times. So we oftentimes have rainy seasons in Australia and all linked to the sea surface temperature. So your understanding of these sea surface temperature effects and your ability to forecast has advanced tremendously in the past decade, right? I mean, we had drought in 2011 in Somalia. Nearly 250,000 people died. But since then, you have more cooperation among agencies, and you really have moved forward in your ability to forecast. And now you can forecast up to 6 months ahead of time, which gives the agencies opportunity to address some of these issues and to be prepared.
That's right. It's right. It's really, exciting in terms of how quickly we're advancing as a scientific community on these fronts, and in a way, I think it's a relatively simple combination of 3 things. One is just, decades of research into the Indian Ocean Dipole and La Ninas and El Ninos. I mean, these are things that we're familiar with. And then, I think it's the ability of the climate models to predict these things pretty darn well, in part because they were developed to predict things like El Ninos and La Ninas, right? So they're really good at it. But then I think the third thing is an appreciation that climate change is producing, very frequent extreme states, and that these models can capture. And I think that needs to be a filter by which we interpret these results. And so, if you combine those 3 things, it's, in a way, it's relatively easy to do the work that we do here at the center, and I think the fourth thing is that now there's, I think, a growing recognition of that potential. And I think a good example of that would be in June of 2020. I sat down and used techniques that we had done in the past to predict the October, November, December rains with observed sea surface temperatures. So we had used that to predict a drought back in 2016. But that in 2016, I had done that forecast in September. And now I sat down in June with the climate model forecasts, and I was like, holy moly. You can look at scatter plots of this stuff, right? I mean, so you can know if you know. And I was like, gosh, this looks like, we're getting good R² values, and it looks bad. And so, we posted a blog post and shared it with FuseNet, and they factored this into their food security outlooks. But that was a relatively small ripple, right? I mean, it was good, but then a bunch, 3 more droughts happened, all of which we predicted. And at the same time, we were engaging with our partners, World Food Program, FAO, the Food Security and Nutrition Working Group, the WMO, all these different groups to try to work together to raise awareness of these events. And so when this May, right, we saw forecasts coming out of the climate models that looked like they were predicting a La Nina and, anticipating yet another bad season in East Africa. Something like 14 agencies collaborated, and within a week put out an alert saying, hey, this, La Nina like forecast is problematic for East Africa and a drought is likely. And that's pretty stunning, right? I
Well,
mean,
that's
so
extremely powerful to get all of these agencies to collaborate. And then you have people looking at different aspects. You have people looking at conflict, you have people looking at the food production and, all aspects. So it's great to have that collaborative network and to be working together. And I think that's what evolved from the early famines and realizing that nobody could be a lone ranger and you had to work together. And that's and it gives people confidence in those forecasts, when they see so many agencies behind them, and they're all motivated then and trying to address the issues. So that's really great. And you mentioned earlier, you work with NASA and stuff. And so I think what's nice about your work also is that you are using data from a bunch of different scales. You're using satellite data and ground-based data, and you developed long-term records so you can understand, where these recent droughts fit in terms of what you've seen in the past and how severe they're going to be. I mean, I see some posts where you say this is good, the worst drought in 70 years, like you were saying, since the 50s. And, it's really nice to have that context. So maybe you can describe a little bit about the different data sources that you pull together and your collaboration with NASA and other groups.
sure, yeah, I'd love to do that. Um, yeah, and by the way, Bridget, I to plug another book, a lot of which is freely available. I have a book on drought early warning,
Ah,
and actually most of that is copyright free because I wrote it as a government employee. So anyway, for students
right.
or whatever, that's kind of a primer on a lot of this stuff. Um, yeah, and so one of the things that we do at the Climate Hazard Center is kind of think strategically about how to do early warning systems. And so, a really important aspect of that is that we want to try to, take advantage of multiple sources of information. And, we tend to think about that, in a staged early warning framework. There's a computer science term called defense in depth, which is kind of, similar. It's like the idea that like, if you want to, make your computer system secure or your castle secure, you don't just have like one door, right? You have multiple chances. And so, um, you know, maybe I can kind of work backwards from a famine and explain it. So, if we have a famine, um, that's preceded, so that ironically, famines typically happen just before the next harvest, right? So if the crop fails, then people have some food, and then the food runs out, and the hunger is the greatest just before the next harvest. And so there's this sort of lag. And so, a big part of the meat and potatoes work that we do for famine prevention, is monitor crop failures. And you can do that using, satellite observed vegetation, hydrologic simulations, and my personal specialty is providing precipitation data sets. And furthermore, precipitation data sets that are really well suited to putting current uh, water deficits in historic context, so that you can say, you know, um, this is the worst drought in 70 years. And, there's a lot that goes into getting the best available station data, combining it with satellite estimates that are very homogeneous and consistent, and high resolution climatologies. And so that's a big part of what we do here at the center, and that's very valuable. And then you can go, I guess, with even more early warning, where we have, weather forecasts of precipitation, which, are really quite skillful, and then you can go even further back, kind of climate outlooks, like we started off discussing. And, we want to use all of those tools, and, that it's kind of like playing golf, right? You start with a driver and end up with a, putter, so that you can have different tools at different times in the season.
Well, it's great to have the collaborative network also, which has evolved over time, and that FuseNet allows. You have the US Geological Survey, you've got NASA, you've got a whole bunch of agencies. You have USDA, Department of Agriculture, and all of these different groups working together. And I noticed on the web that, that the USAID is putting forward like 1.3 billion in funding for famine and food security issues in East Africa, and the World Bank is putting forward like 2.3 billion for East and South Africa.
I hadn't seen that. Wow. Yeah.
Yeah. So, I mean, I think, it really helps to have this collaborative network, and so that people have confidence in the forecasts and know that people are looking at them from a variety of different standpoints, and then that the agencies are responding and providing the funding then for these emergencies and stuff. And hopefully some also goes into longer term sustainability issues. I know food is not your bag, but I mean, I think the Ukraine issues also are probably exacerbating some of the issues in East Africa now, because they used to import wheat and stuff, and so that's not helping. But also the World Food Programme, provides food in these areas that are vulnerable. But I was talking to some people, and they said the World Food Programme works with providing food from local regions if they can access it. And I think what's interesting about that and your precipitation forecasting is that you see large differences between North Ethiopia and South Ethiopia responding to different climate teleconnections, El Nino or La Nina. And so when you have food insecurity in South Ethiopia, you might have an excess in North Ethiopia. Or, people used to talk a lot in the past about East Africa versus South Africa, that dipole and responding to different El Nino conditions. So that helps with the food security issues too and stuff. And
Yeah. And yeah, for sure. You could certainly imagine, a sub-Saharan African future where you had, much better roads, much better grain storage, much better water storage, better market policies. I think Tanzania's exports are shut off. I think, you know, so there's a policy aspect to this too. So it's not just, could you ship food, but will you ship food, but you could imagine a future where, markets and trade, could really smooth out a lot of these local or regional kind of climate impacts.
right. And what you were describing for East Africa, the Eastern Horn of Africa, also extends into the Yemen region, right? I mean, a lot of, or does it? Not really.
It
No.
it extends into there's a smaller rainy season in March, April, May, and I think it does bear some impact on that. I'm not. I don't know. Their main rainy season comes in the summer,
Okay.
and I haven't studied that one.
And
Um,
what I like about the FuseNet website and stuff, that you also consider conflict issues, and so you're really trying to understand what the causes of the food insecurity, water insecurity, and other issues are, and considering a lot of different factors, because you need to understand those if you're going to try to resolve the issues. And so working in these large groups helps you address many different topics. I mean, I think we have a parallel in the US with many of the things that you're doing. I mean, I think the US Drought Monitor brings together a lot of different data types and data sources and stuff. And it's fantastic to look at that when we're in drought, and look at the time series, and you're living in California where you see these droughts and floods and stuff, and so having that those data are very valuable. And then you mentioned, maybe in the future Sub-Saharan Africa can move forward with improved roads and all that. So in California we're still trying to address those issues, trying to take stormwater and flood water and store it in depleted aquifers, and change how we manage reservoirs with these wet and dry cycles. And so I think, this is the way it's going to be for many regions with the increased intensity of these climate extremes.
Yeah, and I think absolutely, Bridget. And I think an important thing to remember, is that a climate hazard, has a climate shock component, and we certainly seem to see climate change exacerbating that. But there's also aspects of exposure. So for the classic example, I think, is if you look at real estate on the southern coast of the United States, where hurricanes strike. You see these big increases in the economic losses associated with hurricanes. And I think there's the WMO thinks that there's a pretty credible fingerprint of climate change on that. But you also have increasing exposure due to people, like the example in California is that if you look through the drought, I think the acres of almonds planted, it's gone up every year. So you have this kind of bizarre, perverse incentive where, there's a drought, the prices for pecans and almonds have gone up. And so the acres planted for almonds have increased, drawing yet more water out of our aquifers.
Right. And the California with the Sustainable Groundwater Management Act are trying to address that over the next, 15, 20 years. And but I mean, in the past, if you had a drought in California, you were growing a seasonal crop, an annual crop. You could fallow during that drought. The tree crops and these perennial crops, almonds and pistachios and things like that, you can fallow, and so then you have to irrigate. But so it can get quite complex. But I mean, I think, to discuss your book a little bit, I mean, I really enjoyed reading it. I mean, very conversational, and you learn a lot, but you're trying to put forward a couple of key messages, I think, which came across and resonated with me. Most of the time in the past when I've thought about climate change, it's always been precipitation trends, and we really couldn't figure it out or whatever. But I mean, the impact of temperature is very important, and the ability of the atmosphere to hold moisture. So maybe you can describe a little bit about what motivated you to write that, and what the feedback has been from that.
Sure. Well, yeah. So, I mean, the motivation for wanting to write the book began with some climate change attribution studies that were associated with the 2015-16 El Nino, and then the 2016-17 La Nina, and droughts in Ethiopia, Southern Africa, Somalia, and Kenya. Basically where we showed that climate change essentially amplified the El Nino and then the La Nina, impacting 50 million people, 60 million people. And so I wanted to share that story. But I also wanted to, and I think it's, a heavy lift, but I wanted to try to let people understand how climate change is working. I kept hearing, people asking each other whether they believe in climate change. And I don't think that's the question that we should be asking. right? I mean, because a lot of the parts of climate change are things that we can all understand. And, one of them is the link between warmer air temperatures and the fact that warmer air can hold more water, and then the implications of that for both flooding and droughts. And, this is something that like quite literally we can sense, right? And so, we all know that when it's hot out, that evaporation goes up, right? And we can all understand that in, a warmer parcel of air, by definition, the nitrogen and oxygen molecules are bouncing around faster. They move apart from each other, and that makes more room for water vapor molecules to fit in between them. So, and this is, this is physics, right? I mean, there's just zero to believe it at this point, right? And but it's going forward from that leads to some really, profound repercussions. And, one of them is that in, the rainiest of rainfall events, right, we tend to see more extreme precipitation. So, every degree of warming increases the amount of water in the air by about 7-8%. And that turns out to make a pretty big difference, if you have an extreme precipitation event.
Chris,
And,
you lost your camera for
oh,
some.
video. Oh, sorry. I hit
Okay.
the button by accident. I'm back. Okay. So this is something that shows up, really robustly, both in climate model simulations and in the overall statistics, so Las Vegas, this week is, last week was flooding in Las Vegas and Death Valley, and it can be hard with any one of those individual events to say that this is climate change. I mean, there are people who can do that. And, there's some like interesting discussions in the book about modeling studies of, hurricanes that hit Houston and how you can, do a climate change analysis and attribute part of that to climate change. But there's just no doubt that in aggregate, we see this increased extreme precipitation. However, when it is, the atmosphere is dry, we see another very predictable and very impactful influence, which is that, the ability of the dry atmosphere to suck out moisture from plants goes up dramatically.
And soil, I guess.
Yeah, and soil, exactly, and soil, exactly. And so, this amplifies the effect of droughts in terms of agriculture, in terms of rangelands. And then it also has and this is something that I learned during the book. I mean, so I finished the book and, my great editor from Cambridge came back and said, Chris, you got to add a chapter on Australia because there had been the Black Summer, right? These incredible droughts there. And so, being the person that I am, I couldn't just write the chapter. I actually had to go and get the data. And so I grabbed a bunch of Australian weather data and calculated the dead fuel moisture levels. And so this is the kind of like the desiccation of, it's the desiccation of dead sticks and logs. And it's related to the temperature and humidity in the atmosphere. And so, what I could do is basically test, what a degree or two of warming did to those dead fuel moisture levels. And it's really chilling. What we're seeing with these fires all over the world is that, when those dead fuel moistures drop below about 10%, the that vegetation is just basically like tinder, right? And so when there's a fire, and there's wind and there's, these different things that cause a fire, which are complicated, there's very little to stop it. And we see this explosive spread. And so, so these kind of temperature impacts, are really contributing to desiccation all over the world. And then, you know, when it's humid and it's hot, right, that's also very dangerous for human beings because it's very hard for us to cool down. And so that's yet another kind of risk associated with extreme temperatures.
And then I think another thing that comes across in the book is, the moisture holding capacity of the atmosphere. So then when it rains, it really dumps a lot of water. I mean, I know in California, you get a lot of your rain from atmospheric rivers and extreme events. But what's promising is that we have an improved ability to forecast these things and understand them. And so, I mean, it seemed to me like the drought that ended in 2017 was atmospheric rivers in December, January in California, So we either have too much or too little, which is very challenging for water resource managers and for food production and stuff. But we need to adapt to those challenges. Then I think that's going to be the thing. And we do, I guess, in the water side of things, because we irrigate a lot, and things like that. But places like the Eastern Horn of Africa, where they have very little irrigation, or any part, most of sub-Saharan Africa has very little irrigation, then we're very vulnerable to the climate extremes.
But yes, and I think water storage and irrigation can be, certainly a big part of the solution. But there are also, there are a lot of places in sub-Saharan Africa that are climatically secure. So, like, Western Kenya or Northern Ethiopia, most of Tanzania, Uganda. I mean, it's not that there's not some moisture stress from time to time, but these places are generally climatically stable, and so I guess kind of cycles back to this development question, right? I mean, there really should be a lot that can be done to intensify agriculture. And, you have a lot of really low yielding varietals that have not seen much improvement in the last 20 years. And it takes just as much water to, raise a mediocre, harvest of maize as it does to get a really good harvest of maize, if you have the right inputs and management practices. And so I think there could be a lot that's done, and there are people working to try to do that, of course, to improve agriculture in places where it is climatically secure.
I think it was Barbara Kingsolver who wrote Poisonwood Bible and stuff, and I think she moved from Tucson, I think, to the Carolinas, and she said, I have no business living in Tucson, there's no water or whatever, and now she has her garden and all of that sort of thing. I think she wrote another book about that. But most of us don't think about that, and development. When we talk about all the food that comes from California, we're sort of proud of it, but why do we produce most of our food in a desert? And I think World Wildlife Foundation had a report where they said, could we move the Central Valley to the Mississippi? So I mean, it's not just physical aspects, of course, it's a lot of social and economic aspects that feed into it also. But when you talked about those climate secure areas, maybe we should consider more development in those regions and more food development, and then more movement from those regions to the other regions that are less climate secure and, challenged.
And it's important to realize there are success stories, out there. Like, I was telling you I had a call at 7 this morning, and this was with some people from the Gates Foundation, who've really invested a lot in agricultural development in Ethiopia, and are seeing some really big increases in crop productivity. So there's, I mean, FuseNet by its nature is always, looking out for the sort of, the people who are most in harm's way, which can be depressing. But we also have to remember that there's lots of people who aren't in that category, and there's lots that can be done, to increase, the welfare of people.
Right, and I think, we're in a pretty tough situation these days with increasing energy prices, fertilizer prices, shortages, and then also I was talking to some folks yesterday from United Arab Emirates, and they were saying the workforce in agriculture has greatly reduced since COVID also. So,
Mm.
people that can operate a tractor or whatever in Africa and things like that, So there are a lot of challenges these days, and food security is going to be a critical issue for many regions. But I think what's really promising with your work then is how you can forecast, and you're increasing the length of time that you can forecast, and then all this interagency cooperation, and then funding from groups like USAID and World Bank to help with these situations. So that's all
Yeah,
promising.
yeah, I think it's really important to if you think about climate change as being really expressing itself as a series of extremes, then that opens the pathway to prediction and adaptation. So here would be just one example. One of the things that I'm worried about um, is that increases in humid heat, in places like Nigeria or South Sudan, southern Tanzania, can impact worker productivity, right? Um, but you might, you know, think that we could have pretty skillful forecasts of temperature and systems to communicate that to farmers, right? Such that heat advisories could be put out. And so if you get a fork, say, hey, we think it's going to be pretty cool for the next week, get out and plant, right? Or we think that don't go, watch out tomorrow because it's going to be really hot, right? It's not like we're worried about extreme heat, but it's not always extremely hot everywhere, right? And so, it's a hazard, but it's a hazard that we can try to manage.
Yeah, and so when I was talking to some folks yesterday, I was asking them, they're geneticists and they work in the agricultural area. Could you take advantage of these long-term forecasts? If it's going to be a drought or it's going to be a wet cycle or whatever. But it takes a few years to establish certain types of crops and stuff like that. We were talking about cassava and things like that. So, but I mean, as we move forward, I think we will figure out ways to adapt to these things, and then with improved communication with nearly everybody has cell phones, even in Africa, so I think we'll be able to communicate the results more readily, and people hopefully understand then what they can do to adapt to these extremes.
That's right. That's right. And one of the things that and we haven't really talked much about our friends in East Africa and Southern Africa, right? And so, one of the exciting things for me is working, with the national Met agencies, with the regional climate centers, and um, helping them get access to a lot of the information sources, the forecasts, things like that, and linking them up with advisories. And we're seeing that already happen, and expanding that is pretty exciting.
Right, and satellite data and everything is just really helping, provide coverage in areas where we might not have good ground-based coverage. I know Byron Tapley here said many years ago, we could use the vegetation responses like a precipitation network in Africa, because so there are a lot of different ways to deal with things. Well, I'm really impressed with your work, and I really appreciate your taking the time to write these books, because, I mean, it reaches a much broader audience, and, even the simple graphics helps us all understand better the fundamentals, and then, we can figure out better what's going on, and try to deal with it. So I know you mentioned before, you developed the CHIRPS precip system, that incorporated satellite and ground stations. And now I understand you mentioned that you're going to try to expand with the temperature monitoring and stuff. So I think that would be very valuable going forward.
Yeah, that's our long-term. I mean, we have a product called shirts, cleverly enough. And what's cool about that is that you know, if you screen out the clouds, you can use the satellites to see, the temperature of the Earth's surface. And it can really be useful in a place like Mali or Senegal or Somalia, where you don't have any nearby air temperature observations. And so, yeah, so our long-term goal or intermediate goal is to get that set up and updated frequently, and then, linked to weather forecasts. And so that would, it's kind of where we would like to be in 5 years, I think.
Right, right. Well, thank you so much for taking the time to talk with me today, and to the listeners then. And we will try to support this podcast then with a website that incorporates a lot of linkages to many blogs and everything that you have been doing recently.
Oh,
and
okay.
And greatly appreciate your trying to do so much outreach in addition to the heavy lift of research. So good luck with your work, Chris, and
Okay.
staying in touch.
All right. Thanks very much, Bridget. This has been a